Let's find the indicated partial derivatives. First, we find the second order partial derivative of f with respect to x. And for this, we have to first determine the first order partial derivative of f with respect to x. So I differentiate f partially with respect to x, which is written as a partial derivative of f with respect to x. And when we do this, we treat y as a constant. So I'm going to differentiate 5x cube y partially with respect to x. So I'm considering this 5y as a constant, and then differentiate x cube with respect to x, that is 3x squared. This is using the power rule. Plus, we then consider this 2 and y cube in the next term as a constant, and then differentiate x with respect to x, which is 1. So let's simplify this. So we have the partial derivative of f with respect to x, and this equals 5 times 3 is 15. And then put this x squared term and then y plus here we have 2 times 1 is 2, so it is 2y cube. Let's say this equation is equation number 1. Now we differentiate equation 1 with respect to x, that is partially with respect to x. So I write down this as the second order partial derivative of f with respect to x. And once again, we treat y as constant. So therefore, when we differentiate this expression partially with respect to x, we treat this 15y as constant, and then find the derivative of x squared with respect to x, which is 2x. And then when we differentiate 2y cube with respect to x, this is considered as constant. So therefore, this becomes 0. And so this simplifies to 15 times 2 is 30. We then have x and y. So it is 30xy. So therefore, we have determined that the second order partial derivative of f with respect to x, and this equals 30xy. Let's say this is equation number 2. We have now determined the second partial derivative of f with respect to x, and so therefore we can write this as 30xy. This is from equation 2. Now we will determine the second partial derivative of f with respect to y. So therefore we start off with the function f. First we find the partial derivative of f with respect to y. That is, we write partial derivative of f with respect to y. And when we do that, we consider x as constant. And so this equals, we can consider this expression as constant, that is 5x cube. And then derivative of y is 1, so we put 1. Plus consider this 2x as constant. And then find the derivative of y cube with respect to y. So using the power rule, it is 3y squared. Let's simplify this. So we write partial derivative of f with respect to y, and this equals 5x cube plus here we have 2 and 3. So product of these two will be 6, and then 6x y squared. And let's say this is equation number 3. Now we differentiate equation number 3 partially with respect to y, so that we get the second order partial derivative of f with respect to y. And so therefore I write second partial derivative of f with respect to y, and this equals here we should consider x as constant. So when we differentiate 5x cube partially with respect to y, this is constant, so it becomes 0. And then for the next term, the 6x will be a constant, and we find the derivative of only the y squared, which is 2y. And so this simplifies to 6 times 2 is 12. It is 12xy. So we see that the second partial derivative of f with respect to y, and this equals 12xy. Let's say this is equation number 4. We will now determine the second order partial derivative of f with respect to x first and then with respect to y. So for that, we are going to consider the equation in 1, that is a partial derivative of f with respect to x, differentiate this partially with respect to y. So therefore, we write the second partial derivative of f with respect to x first and then y. This basically equals the partial derivative of f with respect to x first and then partially differentiate this with respect to y. So therefore, this equals the partial derivative with respect to y of partial derivative of f with respect to x is, I'm going to use this expression from equation 1. So it is 15x squared y plus 2y cube. We differentiate this expression partially with respect to y. And this means we should treat x as constant. So therefore, I'm going to consider this 15x squared as constant. And so I write 15x squared. Partial derivative of f with respect to y is 1. This is, so we are differentiating partially with respect to y. So therefore, it is 1. And then the derivative of 2y cube with respect to y is, using the power rule, it is 6y squared. And so this gets simplified to 15x squared plus 6y squared. This is partial derivative of f with respect to x first and then with respect to y. It says this is equation number 5. We will now determine the partial derivative of f with respect to y first and then x. So for that, I'm going to consider the equation 3 and differentiate this partially with respect to x. So therefore, we write the partial derivative of f with respect to y first and then x, and this equals partial derivative of f with respect to y first and then differentiate this partially with respect to x. So therefore, here we can replace the partial derivative of with respect to x of this expression, that is 5x cubed plus 6xy squared, using equation 3. And so we are differentiating partially with respect to x, which means we treat y as a constant. And so the derivative of 5x cubed is 15x squared. And then for the second term, we have to treat y as constant. So we write 6y squared, and then the derivative of x is 1. And so this simplifies to 15x squared plus 6y squared. This is the partial derivative of f with respect to y first and then x. And thus we have determined all the partial derivatives.